Welcome back to another exciting day of algebra. Today we are starting with our second section on basic exponent rules. Take a moment and pause to write the objective. You'll be writing, I will be able to use the product, power, quotient, zero, and inverse rules to simplify exponential expressions. Take a moment to write down the two warm-up questions, pause, and then come back and check your answers and see how you did. For number 1, were you able to come up with 36x to the 6th power? You would have come up with that by multiplying the two coefficients to get to 36. When you multiply x to the 4th times x squared, you add those exponents and get x to the 6th. Now, number 2 has a little different problem. We have an exponent sitting outside the parentheses. You need to distribute that to the -2 as well as to the x to the 6th. When you do that, that means you have two -2x to the 6th powers. The same is true for the blue. Because the exponent is a 3, that means you have 4x squared 3 times. If you were to then multiply with the red, coefficient times coefficient, you would get 4, and then add the exponents, and you would have gotten 12. For the blue, if you multiply your coefficients, you would have 4 times 4 is 16, 16 times 4 is 64. Then add the exponents, 2, 2, and 2, and you would get 6. You would then take those two terms, the 4x to the 12th, and multiply it by 64x to the 6th. Your final solution is 256x to the 18th. That came from the fact that you multiplied 4 times 64 to get the 256, and then you added your exponents 12 plus 6 to get the 18. Take a moment and make any corrections that you need on your notes, please. Next, we're going to start with our new rule, the quotient rule. It says when you have the same base, x to the 11th over x to the 5th, you will basically subtract the exponents, m minus n. Visually, I would like to challenge you to take a moment and actually write out the 11 x's that are represented by x to the 11th. This is the only problem that I will ask you to write all the way out. So please take a moment and actually write them all out. On the bottom, if we have x to the 5th, that would be x times x times x times x times x. Just like when we've had fractions in the past, like 3 divided by 3, the answer was 1 because they reduced. 3 divided by 3 is 1. The same is true with our x's. X divided by x is 1. X divided by x is 1. That continues all the way until we see that we have 6 x's left over. So the final answer is x to the 6th power. Now, of course, we're not going to want to write this out like that every single time. So the shortcut is that you take the two exponents, the 11 and the 5, and you simply subtract them. It would be x to the 11 minus 5. So the quick way to get to the answer is just x to the 6th power. Same answer, much quicker way to get there. But I wanted you to visually see why the answer was what it was. Now looking at example B, it's a little different. We have coefficients in front of it. -24 over 6. We're going to reduce that. 6 goes into 24 4 times. And then the signs are different, so it's a -4. My x's, I'm going to subtract the exponents. 5 minus 7. So when I continue, that's -4 x to the -2nd power. We do not want exponents in a negative power. So the negative 4 stays where it is because its exponent really is a 1 because there's 1, 4. But the x to the negative second needs to go down to the denominator to become a positive exponent. So the final and correct answer would be negative 4 over x squared. Looking at the third example on this section, we're going to do the same thing of dividing the coefficients. 15 divided by 3 is 5. And then I'm going to look at my x's exponents, 12 and 9. I'm going to subtract them, 12 minus 9. Then I'm going to look at the y's exponents, 7 and 2, and I'm going to subtract them, 7 minus 2. So now, to simplify and finalize our answer, we have 5x to the third, because 12 minus 9 is 3. And then we have y to the fifth power, because 7 minus 2 is 5. So the final answer there is 5x to the third, y to the fifth. Now the next rule we have already talked about in Unit 7. However, we're going to officially master it today and continue using it. The rule says anything to the 0 power is 1. Please notice in example A, the whole term is to the 0 power. So the whole thing is 1. When you look at example B, and if you do the same steps we did on the previous slide, and you subtract your exponents, you will get x to the 0 power. And we just said anything to the 0 power is 1. A problem I would like you to swish into your notes right now is if we have negative 3x to the 0 power. There are no parentheses here. So that means x to the 0 power is 1, but that negative 3 is not to the 0 power. That negative 3 is still there. Negative 3 times 1 is negative 3. So we just need to be careful on the difference when they are all in parentheses to the 0 power, everything is 1. If there are no parentheses, then the one part that is to the 0 power is 1. But don't forget to then multiply it by the negative 3 to get your final answer of negative 3. The next rule is the inverse rule, which we also did preview in Unit 7. Anytime you end up with an exponent that is negative, you must take its reciprocal or inverse and flip it. So for example, a to the negative n, that is a negative exponent. Right now, it's a over 1, so if we flip it and take the reciprocal, it's 1 over, and when you do that, the n is now a positive n. Taking that idea, x to the negative fourth is really x over 1, so the x needs to go downstairs to the denominator to become a positive exponent, and the 1 goes to the top. We flipped it. Example B is slightly different here. The 5 does not have any negative exponents. It's really a positive 1 because there's 1 5 there. However, it's the x that has the negative exponent. And right now it's in the denominator, so if I move it up to the numerator, it becomes a positive exponent. The last one I'd like to look at right here, we're going to divide the coefficients first, like we practiced earlier. 12 divided by 2 is 6. The x exponent is negative, so I'm going to send it to the denominator to make it a positive exponent. The y's exponent is also negative, but it's in the denominator, so it must move upstairs to the numerator to become a positive exponent. Please note the 12 divided by 2, which was 6, did not move. Its exponent is a positive 1 because there's 1 6 that is sitting there. It is the x and the y that had the negative exponents that had to move. Okay, so now it's time, instead of me guiding you through, it is time for you to take some practice problems and see if you can apply the rules we just talked about. Here is the list of the order that you would do your steps in. I will read them aloud, or you can pause it and write them, and then come back and listen after you've written them. First, you will look for zero exponents and take care of those. Second, combine any like terms in parentheses if it's possible. Third, you will swap the negative powers to make them positive powers. That's the inverse of moving it up and down. Then you will look for the power rule to eliminate parentheses. That's where you distribute your exponents. Once that is done, then you use the product or quotient rule to simplify. Remember, we multiply the coefficients, the constants in front of the variables, and then we add or subtract the exponents of like letters. Once you have that down, I would like to challenge you to work on these two questions in your notes. When you're done, unpause the video and check your answer. As you come back, look and see how you did. On number 1, did you make it to 7x to the 5th? If you did not, please take a minute, look at your work, and make any corrections you need. Number 2, did you make it to the final answer of 4x to the 5th over y to the 3rd? If you did not, this one was a little tricky with the negative exponents. Take a moment, look at the work, and make any corrections you need. Next, I would like you to try questions 3 and 4. Pause the video and come back and check yourself. Welcome back. How did you do? Number 3, the whole thing is in parentheses to the 0 power, so the whole thing equals 1. When you look at number 4, don't get tricked because there's a 0 exponent. Yes, x to the 0 is 1. However, you still have y to the 3rd. So your answer of 1 times y to the 3rd is y to the 3rd. Take a moment, look at questions 5 and 6, work on them, pause the video, come back and check yourself and make corrections as needed. So when you look, how did you do? Did you get y to the 4th over x to the 3rd? They both had negative exponents, so they both needed to take the inverse and flip themselves. Now they are positive exponents. When you look at number 6, this is where showing your work and taking your time is going to come in handy. When you go to subtract the x's exponents, you would have had 2 minus negative 4. If you keep change, that actually becomes 2 plus 4, which is 6. The same thing for the y's, negative 2 minus negative 5. Keep change, you actually end up with negative 2 plus 5, which is 3. If you made any mistakes, now is a great time to pause and make the corrections in your notes, please. All right, here is the biggest problem of them all. If you are comfortable with this question, you could tell yourself that you have mastered 9.2. When you look at this question, I hope you see parentheses and an exponent outside. When there's an exponent outside parentheses, that means we distribute that exponent. That would be 16 squared x to the 10th power. Don't forget to distribute it to the denominator. That becomes 4 squared x to the 4th power because we distributed it both to the coefficient and to the variable. If I were to now simplify that, 16 squared, which is 16 times 16, is 256. X to the 10th. The denominator, 4 squared, is 16. X to the 4th. That takes care of the first fraction. Now I'm going to look at the one over here. I'm going to take that exponent 3 and distribute it. That is 8 to the 3rd power. That is not 8 times 3. That would be x to the 33rd power all over 4 to the 3rd power x to the negative 9th power. Take a moment, make sure you're okay with all of that distribution. If I now do 8 to the third power, 8 times 8 is 64. 64 times 8 is 512. And then x to the 33rd, all over. 4 cubed, 4 times 4 is 16. 16 times 4 is 34. I now have a fraction for both the purple and the red. I am going to simplify the first fraction. 256 divided by 16 is 16. If I subtract the exponents, 10 minus 4, I get 6. Take a moment, make sure you're okay with that. I divided the coefficients, and then I subtracted the exponents. Looking at my red fraction, 512 divided by 64 is 8. If I subtract my exponents, 33 minus negative 9, keep, change, that becomes 42 for the exponent. My final step now is to multiply coefficient times coefficient. 16 times 8 is 128. And then add the exponents. 6 plus 42 is 48. If you were able to follow that process, you could say that you have mastered 9.2. That is it in a nutshell. Please take a moment and write down any questions, star any problems that you would like to talk to me about in class tomorrow. Those are the questions I am looking forward to answering.